Hi, everybody. Today we're going to be looking at Lesson 4, Experimental Design, and we're going to learn how to describe experiments. We're going to learn how to randomize. What does randomizing mean? And you're going to learn how to analyze experimental designs. So we have some vocabulary here, and I'm just going to highlight keywords. So in describing experiments, we have what is called a controlled experiment. Two groups are studied under identical conditions with the exception of one variable. So we have identical conditions, and there's one variable that's a little bit different. A control group is the group under ordinary conditions that is subject to no treatment. A treatment group is the group that is subject to the treatment. Makes sense, right? Randomization, you hear that a lot in the news today. Randomization is a process of randomly assigning subjects to different treatment groups. Randomly assigning subjects. Randomized comparative experiment. Subjects are randomly assigned to the control group or the treatment group. So that's very important. Randomly assigned to either a control group or a treatment group. And a placebo. Placebo is a harmless, unmedicated treatment that resembles the actual treatment. So you'll give someone a little pill that they think actually has medicine in it, but it doesn't. And you want to see if does the person respond just mentally thinking they're getting a treatment. So that's a really cool vocabulary word. All right. In some cases, subjects in the control group are given a placebo. The comparison of the control group and the treatment group makes it possible to determine any effects of the actual treatment. Randomization minimizes bias and produces groups of individuals who are theoretically similar in all ways before the treatment is applied. Then conclusions are drawn from an experiment that is not a randomized comparative experiment may not be valid. So you have to make sure you're following all the appropriate steps for an experiment, that it truly is randomized, that it's not biased, and that you're dividing groups either into a control group or a treatment group randomly. All right, let's take a look at some examples. It says, determine whether each study is a randomized comparative experiment. If it is, describe the treatment, the treatment group, and the control group. If it's not, explain why not, and discuss whether the conclusions drawn from the study are valid. All right, so number one, we have Health Watch. At a health clinic, patients were given the choice of whether to take a dietary supplement of 500 milligrams of vitamin C each day. 50 patients who took the supplement were monitored for 1 year, as were 50 patients who did not take the supplement. At the end of 1 year, patients who took the supplement had 15% lower cholesterol levels than patients in other groups. So we want to understand whether or not this is a randomized comparative experiment. All right, and it says that patients were given a choice. All right, so that means it is not randomized. So we're going to write that down here. Patients given a choice, therefore not randomized. So you wouldn't be able to give them a choice. You'd have to randomly select patients for each group. Right, and since this is not randomized, we really don't have to answer any other questions. I do have a little bit more on my answer key here, which I'll read you. I don't think you have to write all this, but I did say the conclusion that vitamin C lowers cholesterol may or may not be valid. There may be other reasons why patients who took the supplement had lower cholesterol levels. For instance, patients who voluntarily take the supplement may be more likely to have other eating or lifestyle habits that could affect their cholesterol levels, right? So mainly we just want to understand here, since they were not randomly selected, we do not consider this a randomized comparative experiment. All right, so number two, check out even faster. To test the new design of its self-checkout, a grocer gathered 142 customers and randomly divided them into two groups. One group used the new self-checkout, one group used the old self-checkout to buy the same groceries. Users of the new self-checkout were able to complete their purchases 16% faster. All right, since we randomly divided the groups, this is a randomized comparative experiment. So I'm just going to write it is randomized. We like that. Okay. The treatment group. All right. So the treatment group are the ones that use the new self-checkout. All right. And the control group are the ones who use the old checkout. All right. So that answers number 2. Number 3, early birds make better drivers. A recent study shows that adults who rise before 6:30 a.m. are better drivers than other adults. The study monitored the driving records of 140 volunteers who always wake up before 6:30 and 140 volunteers who never wake up before 6:30. The early risers had 12% fewer accidents. Well, the individuals were not randomly assigned to the control group or a treatment group, so this is not a randomized comparative experiment. So we're going to just write number 3 here. Should have wrote number 2 here. For number 3, this is not randomized. Okay. I have here the conclusion that early risers are better drivers may or may not be valid. There may be other reasons why early risers are better drivers. For instance, the early risers may also go to bed much earlier, so they get more total hours of sleep, which could affect the number of accidents they have. So bottom line, since we didn't pick them randomly to go into each group, we can't consider this survey valid. It's not a randomized comparative experiment. All right. Randomization in experiments and observational studies. Good experiments and observational studies are designed to compare data from 2 or more groups and to show any relationship between variables. Only a well-designed experiment can determine a cause and effect relationship. All right, so we have some definitions here. In experiment, individuals are assigned at random to the treatment group or the control group. In an observational study, when possible, random samples can be selected for the groups being studied. A rigorous randomized comparative experiment, by eliminating sources of variation other than the controlled variable, can make valid cause and effect conclusions possible. An observational study can identify correlation between variables, but not causality. So we see that there's some sort of relationship between the variables, but we're not necessarily proving one causes the other. Variables other than what is being measured may be affecting the result. All right, let's look at some examples of what we mean. Explain whether the following research topic is best investigated through an experiment or an observational study. Then describe the design of the experiment or the observational study. So you want to know whether vigorous exercise in older people results in longer life. All right, so we're not going to do an experiment because we don't want older people who haven't been exercising to all of a sudden start exercising. That could cause a big problem. So in this case, we definitely would prefer to use an observational study. Right, randomly choose one group of individuals who already exercise vigorously. Then you choose a group who do not exercise vigorously. Monitor the ages of the individuals in both groups at regular intervals. Note that because you are using an observational study, you should be able to identify a correlation between vigorous exercise in older people and longevity, but not a causality, right? So describing this experiment, we would say randomly choose one group who already, keyword here, vigorously exercise, and then randomly choose one group who do not vigorously exercise. All right, number 5, you want to know whether flowers sprayed twice per day with a mist of water stay fresh longer than flowers that are not sprayed. So obviously we're applying a treatment here. This is going to be an experiment. We randomly select the same number of flowers to be put in each group. And then we're just going to apply treatment to one group and not the other. A lot of writing in this unit. You keep all the other variables constant, same amount of sun, things like that. And then you just record how many days the flowers in each group remain fresh. An important part of experimental design is sample size, or the number of subjects in the experiment. So if you think about it, if I was trying to form an opinion about what the sophomores think about their favorite music genre, right? And I only asked 10 sophomores. And then instead of asking 10 sophomores, then I asked 200 sophomores, and we compared the results. Well, which one would you be relying more heavily on? You would be on the one that I asked 200 people, right? So sample size is extremely important in experimental design. To improve the validity of the experiment, replication is required, which is repetition of the experiment under the same or similar conditions. The validity of an experiment refers to the reliability of the results. The results of a valid experiment are more likely to be accepted. All right, so we've got a couple more examples here. Be prepared to write some more. A pharmaceutical company wants to test the effectiveness of a new chewing gum designed to help people lose weight. Identify a problem, if any, with each experimental design, then describe how you can improve it. The company identifies 10 people who are overweight. 5 subjects are given new gum and 5 subjects are given a placebo, which is a fake gum. Or it's a gum, it's a real gum, but it doesn't actually have a treatment. After 3 months, each subject is evaluated, and it is determined that the 5 subjects who have been using the new chewing gum have lost weight. All right, so the problem right here, right out of the gate, is that we only have 10 people. So the sample size is not large enough. All right, it's not large enough to produce valid results. All right, number 7, the company identifies 10,000 people who are overweight. The subjects are divided into groups according to gender. Females received the new chewing gum and males received the placebo. After 3 months, a significantly large number of the female subjects have lost weight. All right, well, we have enough people in our survey here. We've got, 10,000 people looking at this. The problem is that the groups are not similar. I mean, one group is all female and one group is all men. All right, the new chewing gum may have more of an effect on women than on men, or more of an effect on men than on women. It's not possible to see such an effect with the experiment the way it's designed. The subjects can be divided into groups according to gender, but within each group, they must be randomly assigned a treatment or a control group. All right, so we'll just add a little note here that within groups of female or male, must be assigned treatment and control in both. All right, number 8, last one. The company identifies 10,000 people who are overweight. The subjects are divided into groups according to age. Within each group, subjects are randomly assigned to receive the new chewing gum or the placebo. After 3 months, a significantly large number of the subjects who received the new chewing gum have lost weight. All right, so the subjects are divided into groups according to a similar characteristic. Because subjects within each age group are randomly assigned to receive the new gum or the placebo, replication is possible. So this is a valid study. We've met everything we need. We have, a large enough group of people. We've divided into groups, but within each group, we're randomly assigning some to get the actual chewing gum with the medicine in it and some to get the placebo. So this one is a valid study. Okay, that's all I have in this lesson. I hope you enjoyed it. Like I said, this is a very different kind of math, a little interesting, real world application type problems. Keep these notes handy because you will need to reference the vocabulary on any assessments coming up. All right, guys, have a great day.